My name is Aubrey Russell, and today I want to talk about the AWS Hackathon project, Super Creativity. The idea here is to give developers and users the ability to use LLMs through AWS Bedrock, the ability to generate novel and creative output in a high quality way, not just a random and arbitrary way. So in this particular architecture, what I've done is created a graph-like structure in AWS that involves various types of nodes. So this particular chart right here showcases the configuration that helps to generate creativity. Now, for example, in this case, we start from an iteration controller, we go to a chaos generator. This will insert some random noise to help ensure that the overall logic is not generating duplicate stuff. So then it goes ahead and involves a sequential process where we use multiple different types of models in different configurations. So I have a high temperature mode, a low temperature mode, another high temperature mode, another low temperature mode. And the idea here is that by combining different models, like for example, if you combined Claude 4.5 Haiku and you combine DeepSeek, then you can get additional novel output based on the differences between model architectures. And this process can be configured to run iteratively, so it's a self-input feedback loop where the process can repeat n number of times depending on how much creative stuff you want to generate. Throughout this process, it's constantly judging and evaluating in order to determine if an idea is any good. So the separate LLM as a judge is going to ensure that this process remains, grounded in reality and actually fulfilling the prompt. So I'll go ahead and get started on this demo here. Now, the main thing is there is a main.graph or main_graph.py here, which has various configurable options. And I'm just going to use the default, but it does use this flow_config.json. And in here, you can see several configuration options. We've got the models. I've just called them A and B. One is Claude Haiku 4.5. The other is Nova Pro. And this is a pretty good example. And then for my chaos generator, I have Amazon Nova Premiere. And then there's a judge, which is Claude Haiku as well for performance. Now, I have also hooked up all sorts of performance improvement elements here, like smart web caching and stuff like that in order to facilitate enhanced performance. So let's get started here and we can kind of show what's going on now. I've got a example prompt inside my launch here where I just have -- prompt and I say come up with the next generation LLM enhancements with a focus on algorithmic and tooling improvements. That's a pretty good one. I want to come up with a creative idea for that. So I'm going to go ahead and boot this up. So great, it's going to go ahead and get started. It's going to start live logging. Now, it's going to start dumping all the contents to an output folder as well. So at the start here, it is attempting to generate related keywords. In this case, I have various options like GenSim or a simple fallback as well in case that doesn't work out so well. And the idea, like I mentioned, is just to give it some of that diversity of inputs so that as the iterations occur, it's not falling back on its old ideas. Okay, great. So it generated some tangential fallback words. It's fine. This will help keep the outputs fresh, and we can see it's proceeding now. Now, this does take a minute because it's doing not only several complex evaluation processes, but it's also doing various logging, and it's doing web search and stuff like that in order to get better ideas. So just give this a second here. Some of the models I have configured are not supporting streamability, which is one of the issues I ran into. So like in this case, I've just turned it off for now. Although with the judge mode, I did enable it. And so certain models don't support streaming, so that's configurable here. That way it doesn't blow up on you. So right now under the hood, it is starting to generate a bunch of outputs. As we can see, here's done the first iteration, which is the chaos input. And so it's just helping to generate some divergent content here that then gets fed. Now we can see as it's being fed into the first creative stage, it is using the DuckDuckGo MCP tooling here to do web search. And I have a global cache system that is able to help either obtain or cache duplicate resources to improve performance here, as bulk searches can sometimes slow down the procedure. So we're continuing to scan here, continuing to search. It's doing a comprehensive job. These prompts are all configurable too. So for example, inside system prompts, we have the ability to say, go into the creative system agent here and configure this to be whatever you want. The judge gets a little more sophisticated. I am using the Jinja 2 templating structure here in order to allow these prompts to be configurable dynamically. So for some of my primary templates that get used in my graph nodes, the judge agent, for example, has various elements for insertion, and using Jinja 2 allows me to do some more sophisticated stuff potentially in the future. So it can also just be a regular .md file for the system prompts too. And I do have all of these cached as part of the execution too. Okay, great. So now it's going through the refinement stage here. This is iteration 0 still. I'm just doing one iteration as a demonstrative purpose, since, as you can imagine, this does consume a decent amount of tokens. But of course, you can tune this to do less aggressive web search, for example, and that would speed up the process significantly. And I do have a bunch of docs here as well that you can look into. Like, I have a particular section for the graph flow here, which can describe the particular process that's going on, and other documents about like the data flow or the LLM as a judge memory system, where we try to evaluate the quality of the output. Okay, great. So here it got through the refinement. That's a blob of text. You can see a more reasonable output here. We can see it started generating some good creative ideas. So in the first one, it did idea 1, for example, hierarchical token distillation pipeline. Build a multi-tier token compression architecture where input sequences are progressively abstracted into concept tokens at multiple levels, similar to how vision hierarchies work in image pyramids. Sounds interesting. Then in the refinement stage, the model itself, in a low temperature mode, attempts to rate and condense all of the ideas that were generated. So as you can see, it starts generating quite a few different possible ideas here. Okay, great. And then the judge process is independent, and in this particular one, it is generating an overview of like originality, feasibility, impact, substance, and overall quality. And you can tune the acceptance criteria here so that it is, possibly rejecting, worse scores overall. So then over here in the memory, we accumulate the ideas, and this is cool because the ideas are, stored here, and their corresponding ratings are tracked as well. And so this way, as iterations progress, we don't have to worry about the duplication of certain ideas. Now, your mileage may vary, and certain models may duplicate anyways because it's a non-deterministic process, and if the context gets too big and whatnot. But generally, this is expected to help reduce duplication of effort over here. So it started on the B creative iteration, and now this is a simpler model here. This is just one of the smaller models I've chosen for demonstrative purposes, and it's coming up with some ideas here, and they are not as thorough as Claude, as you can see, which is understandable. It's a less sophisticated model, and it's optimized for simplicity and token generation rates and stuff like that. So the judge, though, is still Claude 4.5 Sonnet. It's crucial to have that consistent judge so you get that standardized evaluation process. And it has been instructed to follow a JSON output that is very particular in order to actually process that effectively. So yeah, and it comes up, and you can go to each step and, find the creative elements as this iterative process emerges. So great, it even comes up with like next recommended steps to consider. And of course, this could be also used for like writing stories or, coming up with like new app ideas or, whatever creative direction you'd like to go. This can just be a module in your overall A2A process that can be invoked and generate creative inputs for you on the fly. Great. It's generated quite a bit. You scroll down. Now it's still proceeding on. Yeah, so it's still proceeding on here, and it's still hitting the cache here, and we can see that the model is just about done here, I believe. The refinement process is completed, so B has done its own refinement, and the judging process is going to continue. So great, it finally finished. It did its final research as well, which is the final output here. So the final output takes this entire process once it's done after n iterations and generates the recommended creative output. So algorithmic enhancements, advanced parallelism strategies, multidimensional parallelism. That sounds interesting. State space models versus transformers. That also sounds interesting. So as you can see, it's generated quite a bit of high quality creative inputs for based on whatever query you happened to input. So yeah, that's about it. And thank you very much for your time. Much appreciated. And of course, leave any feedback or comments, and have a great day.